Hello everyone. Welcome to the BMES Professional Development Webinar, Entrepreneurship and Innovation in Biomedical Engineering. I'm Kunal Mitra and I'll be your moderator today. I'm a professor in Biomedical Engineering at Ford Institute of Technology, and I also serve as a member of the BMES Education Committee. So before we begin, few announcements. The archived recording will be available shortly after the webinar on the BMES website. You may also submit your questions to the webinar by using the online chat function. Your questions will be addressed after the featured speaker presentations. There will be 2 presentations in this webinar. Please take a few minutes to complete the brief survey following the webinar to provide us with your feedback, and we appreciate that. So please, to get a better sense of who is joining in this webinar today, we'd like to take a few polling questions. To answer the polling questions, select your answer and click Submit directly on your computer screen. Please take about 30 or 40 seconds to answer each question after I read them aloud. The first question, which of the following best describes you? And our second question, have you ever taught as an instructor or taken as a student a course in entrepreneurship innovation? Okay, now we'd like to start our presentations. I'd like to welcome our presenters today, Dr. Mansoor Nasir and Dr. Donald Gaver. Our first presentation will be given by Dr. Mansoor Nasir. Dr. Nasir is an assistant professor of biomedical engineering at Lawrence Technological University. So without further ado, I'd like to introduce Dr. Nasir to take it over. Thank you.
Thanks, Kunal. Thank you to BMES for giving me the opportunity to talk about this entrepreneurial thinking and something that we have been involved with for about the past 5 years now. And so what I will do is give you a little bit of a background about where I come from, and then also then start to talk about how we're implementing some of this entrepreneurial thinking in our campus and in biomedical engineering. So really, I think I want to emphasize that Lawrence Tech, which is a private university in Southeast Michigan, we are able to do a lot of things with the students, especially in classroom, related to entrepreneurial thinking, because as a university on a whole, there is a concerted effort to introduce and inculcate students with this entrepreneurial mindset, which means that people both in administration as well as other faculty, they're all on board in helping with these kinds of activities in classroom. So there's a lot of support available, and I want to emphasize anybody who's on the faculty and administrative side that it is really useful to have that support, so that all the time that is being spent on something like this is actually being acknowledged for the faculty. As I mentioned, Lawrence Tech is a private university in Southeast Michigan. We're about 10 miles outside of downtown Detroit. We have about 3,000 to 4,000 students, which means small class sizes. We're really focused on education and pedagogy, and everybody here is actually doing sort of engineering pedagogy in addition to all the other things that happen in other campuses as well. And so we're regionally recognized for this. And I think that small class size allows us to interact with students and sort of get that close interaction. I just want to point that we opened a new center called the Taubman Complex, which is the home for biomedical engineering, and it has large spaces, studio-style spaces, which are very amenable to these kinds of collaborative learning pedagogies that I'm going to talk about today. So specifically, what I'm going to try to do is, since I saw that there's a fair number of people who are not exactly have taken a course or aware of entrepreneurial thinking, I'll tell you what it is, at least our perspective of it, and then tell you also a little bit about why you would want to take a class in it as a student, or perhaps be introducing it in your classroom as a faculty, and then tell you how we have done it as case studies and examples. And you are more than welcome to reach out to us afterwards, and I'm happy to help you with trying to do this if you're on board with this mindset. So I always like to begin with this slide as an example about how to put it in perspective. This is a common example that's given. So if you can think of these two images that you see, there are two ways to create a dish, a food dish. One, which is shown on the left, is where you actually have a menu and you get the ingredients and make that specific dish. So there's only one outcome in that case. The other, which is perhaps more synonymous with entrepreneurial thinking, is sort of opening your refrigerator and finding out exactly what's in there, and then concocting a new dish. So if anybody has seen Food Network and seen the Chopped Network, I guess you can call those as entrepreneurial chefs. But there is an actual theory and foundational work that's been done really by a lot of it has been put down by Dr. Saraswati at the University of Virginia about this idea about causal reasoning and effectual reasoning. So a lot of times, if you can think of as a jigsaw puzzle or a one outcome that you want, and then you get the expertise as a manager, well, we need these expertise and we'll put it together to get that given goal. There really is only one outcome. But what we're trying to do with entrepreneurial thinking is to give them the Lego pieces, give them the skills, and then sort of motivate them and encourage them to come up with many different solutions. So from this standpoint, I would say that effectual reasoning and entrepreneurial thinking is all about innovation, which is what is, I think, most important moving forward here. With how cheap the knowledge has become, I think what we want to do is to have students who can actually do the innovative part and connect various pieces of information together. But this is still a little bit abstract, and so what I am going to show you is a framework, and this framework is specifically from Kern Family Foundation's Keen Network. We are closely aligned at Lawrence Tech with the Keen Network, and this idea about a mindset and a skill set, so the 3 C's that you see, the curiosity, connections, and creating value, this is really the mindset that we want to inculcate in our students. And then how we actually do that is by having them practice certain skills, which are shown on the graphic, which is on the left. And I'll come back to this when I show you how we have implemented and used these in our classroom, and that's how I'll say it. So this is sort of about what is entrepreneurial thinking and framework and mindset. Let's sort of quickly touch upon why you would want to do this, because an instructor might say, well, this is extra work. What do I get out of it? Well, what I'll try to say, and I think a lot of people in this area will emphasize, is that really what we consider as entrepreneurial thinking or mindset in the end is things and qualities that we want in all engineers, okay? And I'm specifically talking about at the undergraduate level, and I know Dawn's going to talk a little bit about something more focused at the higher level. But what I can tell you is that student learning improves with trying to introduce entrepreneurial-minded learning and activities related to that. And this is not just me saying that, but in fact, there is education research that has been done that has shown that it helps with retention of information. It makes the class interaction better, so it's not all didactic. The students are actually learning by doing. And then really the students are getting prepared for real-world problems so that they can see the connection of the knowledge that they get, the technical information, and how it applies to the real world. And I would say that as an instructor, who doesn't want that for all people in a classroom? From the student standpoint, and we all have to do capstone design as undergrads, you get taught about the biodesign process. And what I'll mention is that a lot of times the students are focused on what is shown highlighted in the blue, the sections which are more technical, right? The design process, the validation, the technical information. That is important, but as a student, you also need to realize that there are many non-technical constraints going from, where is the need, what is present already on the market, what regulations are present, and these have a direct effect on the design process. So what we're trying to say is that, even if you don't go and create your own business, which is in our surveys the #1 response we get. We ask students, what is an entrepreneur or what is entrepreneurship? They say, creating a new business. Yes, that's true, but what we're trying to say is that that's in fact something that you can use even if you work in a large organization, to be that standout person who has leadership qualities and can work in a team and can innovate. Who wouldn't want a person like that? Just a shout out, there are many different programs, and you'll get a chance to hear one about a little bit later, but there are many different programs and foundations and organizations that are doing this for those of you that are new to this area, and so I'm not proposing something that's brand new, but what I will say is that a lot of these programs are focused on a coursework or a specific a program that you take with like an intensive workshops kind of stuff. And what we're really trying to do is, okay, perhaps we're not going to get to that level of involvement, but what we're trying to get is greatest impact. So in that sense, I like this graphic to sort of show that instead of taking a bunch of engineers and putting them with business school and trying to get the best outcome, we're really trying to inculcate all of our engineers, and especially now for the audience that we have, biomedical engineers, with these general understanding of this perspective from the real world, to allow them to become better engineers, or as we call it, sort of a bit of pun, super engineers. How we're doing this? Well, if you want to build a mindset, if you want to have students literally change their thinking, you can't do this once. And so we've taken the approach that we will create modules and we'll actually introduce them in various classes in various levels throughout their education. So I'll share some of these modules that we've introduced all the way from freshmen going up to their senior project classes. A little bit more on this later, but let me talk a little bit about still the framework that we have used. How we actually have done this in a classroom, for those of you that are involved with pedagogy and are aware of this area, you know about the two methods, perhaps the deductive and the inductive learning techniques. Deductive is how perhaps even I was taught, which was you basically get a one-directional flow from the faculty to the students. And inductive is sort of hands-on learning, sort of project-based learning, active collaborative learning. And I would say that this is a great medium to introduce entrepreneurial-minded learning in a classroom as well. And it's not too much of an extension beyond what is already done for project-based learning. So we use inductive learning techniques, and that means that it really enhances the student-teacher interaction in this case. Finally, one more thing. Sometimes what happens is that if you try to do this in various classes and they're disjointed modules, students can't make that connection unless you explicitly make that connection. So we made a considered effort that we'll pick a theme, and we chose this theme of quantified self, or maybe perhaps it's easier known as wearable sensor technology, to introduce this entrepreneurial-minded learning. And the reason why we did that is because, as it turns out, a lot of these wearable sensors are using technology that are the same technology that's also used in medical devices. So you can talk about that. But in addition to that, they're cheaper, so you can bring them to classroom and have many versions of that. So if students want to do a hands-on activity, they can actually really use them. Now it's probably common, you might have seen it in your students. A lot of students are wearing Fitbits, they're wearing other kinds of watches. And so they're users of these devices, so it makes it real. So it's not an abstract device like talking about an EKG meter. You're actually talking about like some kind of a Fitbit device or a Nike Plus sensor, which has capability of measuring similar data. So I think it makes it a real-world and easy to relate to. I also want to mention that this area itself, for those of you that have been keeping up, has really blown up. 4 years ago, when we started this, there was a little bit of it happening in the Consumer Electronics Show, and then the next couple of years, you saw that now they have specific focus on entrepreneurial on the entrepreneurial activity in this area of wearable sensors. So it makes a good case study. Why do the companies succeed? Some of them fail. So we can actually take case studies like that. Okay, so I'll focus now specifically on what we have been doing at Lawrence Tech by starting to show you our flowchart. This is how we advise our students. But what I want you to focus in is that all the courses that are in black and blue are the ones where we actually have outlined in black and blue are the ones which we have introduced our modules in. You can see going all the way from introductory course all the way up to a senior level course. And now it's sort of natural that sometimes there will be a small activity, sometimes it might be part of a project, and we've done that in many classes. So the same theme can be used for a wide variety of courses, anything from anatomy physiology to medical devices to best practices, as you can see. The ones that are in the red are the ones which are sort of university-wide approach for design and entrepreneurship. And these are things that other engineers have to take in the College of Engineering as well. Sort of going back to the fact that there's a focus that's coming from, top down all the way. Everybody's on board with this. So it really helps us sort of put, students through these kinds of activities, many times. And hopefully what that does is allows them to practice and then allows them to really inculcate this, and it becomes a habit, which is what we want. Okay, so I'm going to give you examples based on, it depends on how much time there is. From 3 classes in particular, the intro class, a best practices class, and the medical device design class. And you can see at what level most of these students are taking them. And I have examples for many more, and I'll provide you with a link, and you can always contact me. One thing as a side note I found is that this area, unlike perhaps research, is very, very collaborative. So you'll find people who are willing to go out of their way to actually help you out, and it's very encouraging for anybody who's new to this area. Okay, so let me just start right here with the first slide that you can see. So this one now is going back to that framework. So what you see in the first column are all the different actual skills that we're trying to focus on in these courses. And you can see that some of them we're hitting in each course, some of them we're only hitting in 1 or 2 courses. But the idea is that they're getting repeated exposure. And then based on their level, we can make them sort of not very sophisticated or more involved at the higher level. Okay? So hopefully that will come across in the examples that I'll give you. So this is the first course, which is a freshman level introductory BME course that all students take in their first or second semester. So in this course, we really want them to sort of focus on opportunity recognition, which is to sort of figure out really, where there is a space for a new technology. And we've been doing this with these specific kinds of sensors called these Nike shoe sensors. Side note, Nike shoe sensors no longer exist, and that makes for an interesting case study because as a venture or a side venture from Nike, they failed for various reasons because they were too expensive. There wasn't a market for it. Perhaps the market wasn't ready for it at the time when they were introduced 3 or 4 years ago. So what we're trying to do with these sensors is we give them to our students. We tell them very basic information about how they work. And then we tell the students, well, why don't you go and figure out how they can be used in a different application based on what you know about their working principle. So the students have to go and come up with an application. In this case, because they're just freshmen, what they have to do is just create a pitch video about a new idea. So some of the things that you see down here for YouTube videos are things that our students have created based on how to think they can take an existing technology and retool it for a different audience. So here they're realizing, how to sort of talk about market value, but at a very superficial level. Now I will go to the best practices, which is sophomore level class in here. Now we can start talking about issues of medical devices and what makes a medical device as compared to a consumer device. Sometimes people will take the exact same thing and target towards consumers as compared to a medical device. We can talk about issues of 510K and intellectual property and novelty. How can something exist in a space when there's other devices? It has to have a value proposition. And then give examples like this early sense monitor, which was initially a medical device but then became a consumer device because they decided to go after a different market, and a whole bunch of other parameters needed to be taken into consideration. Again, case studies really help students in trying to sort of learn these concepts instead of just sort of abstract ideas. And then finally, in the medical device class, I will talk about we have a semester-long project, and here we're sort of talking about hands-on learning in class with sensors like the one that you see on the top, which is a handheld EKG meter. We can compare the technologies to say, how is this different from one that's used in a medical or a clinical setting? And what happens if it's a consumer device? What kind of standards and regulations apply to it? And I want to emphasize this note at the bottom that we don't really have to sacrifice the technical content, because that's a concern that a lot of faculty have, that if I do this in a classroom, I'm going to not be able to cover some of the technical stuff. But by integrating it this way, it's not too taxing, and you can really talk about technical aspects. So here's an example. All of these are EEG devices. Some of them are medical, and some of them are consumer devices. They all use similar principles, but some of them are working with dry electrodes, some are working with wet electrodes. So students can focus on the technical aspects, but they can also focus on, well, why would a device exist when there's something exactly similar on the market? What is their selling point? So really, students can focus on examples like these in a classroom. In the class projects, the students will go through this whole ideation process and come up with prototypes. So I can provide more information for anybody who's interested. I say that I'm running short on time. The assessment part is where there is still a lot of work being done in the community, so people are working with tools. What we have seen is that students at least exhibit better familiarity with this, and we have seen, at least in our senior projects, that students are now more comfortable in going to customers and getting their feedback. As this example is shown in a senior project where students actually approached a person who was using a scooter like this, and they told them, you know, tell us what are your problems. They came up with this idea that they don't fold, they're too heavy. And then eventually, once they designed this, they went back and got his feedback to say, well, what do you think about it? So this is really what we want our students to be able to do in comfortable. Engineers who are generally very uncomfortable with this kind of work, we want them to get comfortable with it. On the faculty side, what we have been doing is that we've been trying to create small modules that instructors can use to introduce these in their classroom. And I have really a bunch of people who have been working with me, especially Eric Meyer, who's shown in this image in some of our videos that we've created. He has been the partner in crime at Lawrence Tech. And like I said, there's many other people who are part of the Keen network who've developed these modules for these courses. The website that you see at the bottom, the qs4eml at .ltu.edu, it has sort of an open access to all of these modules and how we introduce them. If you're interested in learning more about this, please contact me. The email was on the first slide, and I'm more than happy to direct you. And we're also looking for other areas that we haven't developed. If somebody wants to come up and use the theme to develop it for their classroom, then we'd be more than happy to work with you and talk to you as well. Again, thank you for inviting me, and I'll hand it over to Kunal now.
Thank you, Mansoor, for an excellent talk. And now I'd like to welcome actually Dr. Donald Gaver. He's a BMES Education Committee Chair, and he's also an Alden J. Dock Laborde Professor and Chair, Department of Biomedical Engineering and Tulane University. So, Don, the floor is for you.
Thank you. I'm very happy to be able to present today at this webinar. I'd like to move on directly to a PhD program that we run at Tulane University as a model for how one can teach bioinnovation to PhD students. This presentation is going to focus on an internship program that we have with the FDA, and we have curricular opportunities also, or curricular performance evaluations that we do as well, but I'm only going to be talking about our FDA program today. So this is a program that is a relationship with the FDA and Tulane University, and it's funded by an IGERT traineeship program with the National Science Foundation. I'm referring you here to our website for Bioinnovation, which can be found by searching on Google for Bioinnovation at Tulane University. Our motto for the program is written here. It's a quote from Albert Einstein. In theory, there is no difference between theory and practice, but in practice there is. And that's an important motto for us because we ask our students to push themselves out in the envelope of what they're trying to do and to evaluate the products that they are creating with the recognition that something that you think might work may not work, and one has to evolve through the process to adapt to an environment. Our general program couples research, non-academic experiences, and entrepreneurship training, and it is, first of all, a PhD program, so it is different from most other programs that are master's level programs. We expect our students to perform a high-quality PhD thesis and do that in the context of innovation and entrepreneurship. The feature that I think is most important for this program are the supra-academic aspects of the program. So here, what we're attempting to do is to have our students experience non-academic opportunities that are best conducted through a liaison with industry and the public sector. And we have a diverse student population, so we're looking for students who can bring different aspects of their background to our program and help each other to work towards entrepreneurial goals. This is not a biomedical engineering program per se. It is an interdisciplinary program at Tulane University and spans all schools of the university. So students come in with backgrounds in mathematics, chemistry, physics, biomedical engineering, chemical engineering, et cetera, and take courses that focus in on bioinnovation. And so there are curricular requirements that our students have to follow. They also enter into a laboratory rotation for the first year where they create, where they develop knowledge of laboratories in our School of Medicine, School of Public Health and Tropical Medicine, and School of Science and Engineering. And by doing that, they learn the different tools and questions that are being used in those laboratories and develop relationships between the laboratories for their final PhD work. They also have business model experiences and learn about entrepreneurship with that. The FDA internship program occurs after their first year, after they've completed their internship, their laboratory rotations. And so that's what I'll be talking about. So I'd like to give you an idea about why this is important to us. So this slide here shows the view of New Orleans that most people in the United States think of. And so it's a beautiful area in Louisiana with a very verdant environment. It's a wonderful cultural mecca. And so that's what most people think about. What we're trying to do here is to build a community of biomedical engineering research and innovation in New Orleans. And this brings together different aspects of New Orleans. So first of all, Tulane University, the School of Science and Engineering, School of Medicine, Business, Law, and our Primate Center, along with a Bio District New Orleans, which is a large area in the downtown region that includes two large health sciences centers, as well as a VA hospital. We also have a Bioinnovation Center that's a state-run Bioinnovation Center and that provides a nice incubator space. And there's a culture of innovation and entrepreneurship here. One feature that may not be known in general is that New Orleans has changed within the last 10 years, and it has now become one of the fastest growing areas for brain gain. And so this slide here shows the increase in domestic migration and the increase in college graduate population in our region. So it puts us at the top of the list in where we are as far as students or former students migrating to New Orleans in order to create careers. So given that this is a PhD program, we have biomedical research projects, and I'd like to go through just quickly 3 slides that define the areas of research that our students enter into. The primary focus is on transport processes seen from a very large scale view. And the idea is for our students to enter into these, into research to develop biomedical technologies and devices. And to reiterate, we look for this to link laboratories between the School of Science, Engineering, Medicine, and the FDA. So the 3 areas, the first is therapeutic materials. So you can think about this as problems related to drug delivery and organs on chip sorts of devices. The next is biosensors that can be used for evaluating diseases or the likelihood of a toxin in a region. We have large research groups in both of those areas, as well as this third area, which is regenerative medicine. And here, this slide is meant to just indicate the scientific issues that come to play if one wants to recapitulate a revascularized tissue that one would want to use for biomedical purposes. Now I'd like to move on to the FDA, and this slide represents the value proposition for our students. So our students enter into this program understanding that they are likely to want to pursue a career in bioinnovation that may be either in academia or in industry. So we want them to be at the interface between academia and industry, and one of the best places to do that is with the FDA. And so our students enter during the summer of their first year to the FDA as employees of the FDA, and the role of this is for them to understand the regulatory environment and process so that after they graduate, they have an understanding of the people and the questions that are being asked by the FDA so that it can help them to work in their postgraduate years with that environment. We've also found that their experiences with the FDA can modify their PhD research in very, very nice ways and allow them to create technologies and devices that might have a reduced pathway through the FDA. So why is the FDA a relevant partner? So this is an obvious slide. The FDA works with bioengineers through hospitals and healthcare facilities, and also in the public sector. And most importantly, the FDA regulates those products that would be created by bioinnovation students. So this list here of the FDA shows the areas that the FDA regulates, from biologics to veterinary products, radiation-emitting products, medical devices, cosmetics. Most recently, tobacco has been added, and also foods and drugs. So the FDA is really at the epicenter of the kinds of issues that we look at as biomedical engineers. Our students work for the CDRH, and the CDRH is the Center for Devices for Radiological Health. And the key issues in the CDRH are efficacy, safety, public health, protection, and promoting good products on the market. And so that's basically the mission, which is to promote and protect public health by ensuring the safety and efficacy of medical devices. So entering into this climate is very important for future biomedical engineers. This is the CDRH organizational chart, and our students enter into the Division of Post-Market Surveillance, where they look at issues that have come out after products have entered into the marketplace and concerns that might arise. So why is this the relevant branch? It's because these analysts monitor post-market medical device adverse events, and so they need to look at signals and investigate trends and analyze those signals to see whether or not there's an issue that needs to be addressed with a product. And so this slide here just goes through the medical device reporting process, and I'll leave that for you to read as you'd like. But what we're most looking at are MDRs, or medical device reports, for events that have been reported to the FDA that may have caused or contributed to death or serious injury. There are quite a number of different paths for MDRs to be submitted to the FDA by individuals, by hospitals, by doctors, and so there is quite a bit of data that is reported to the FDA, and the post-market surveillance has to look to see whether there is an accurate signal that has to be addressed. I like this slide. It's so linear. It shows you the pathway from a medical device report all the way through the FDA and how they work with things. And so our students learn different aspects of this and the process. And this leads to the need for data analytics. There are approximately 1 million MDRs submitted today for about 50 employees in the post-market surveillance group. And so there's literally a flooding of data, and our students can go in and use different techniques to identify whether these MDRs provide appropriate signals. These are highly qualified students to look at data analysis, and they're trained by the employees of the FDA to do data analytics. And so the FDA projects are to look at creating an improved electronic MDR record to try to explain an increase of adverse event reports, to create alternate summary report data so that this waterfall of data can be interpreted, and to create longitudinal studies to track devices from pre-market submission all the way through to the end users. On top of that, our students can become involved with the Office of Science and Engineering Laboratories. So unlike the NIH, the FDA does not run large-scale laboratories that generally include students, but they do have laboratories to develop an understanding of systems and potential problems that might occur with devices that are coming to market. And so this is laboratory-based regulatory research, and it provides the employees of the FDA with a scientific and engineering expertise in order to help support the regulatory process. And we can offer this opportunity to our students. And at the bottom of the slide, I show a biotransport relationship for vaping and material that is transported into the lung as a heat transfer kind of problem. We have learned through our relationship with the FDA that vaping has not been regulated, and that the heat transport and issues in this may change the product that is being vaped if temperatures are too high. And so they have laboratory studies to look into vaping at the moment. And so these laboratory experiences are valuable to our students. And so this slide shows the research of Assis Lopez, who is one of our students, and he's looking at microvessel rupture from exposure to high-intensity therapeutic ultrasound. And that's of importance to the FDA, and it's important for research that's being done at Tulane also. Another aspect that is very enjoyable for our students is their experience with signal meetings. So these are interdisciplinary multidivisional meetings that include FDA employees all the way from pre to post-market divisions. And so if there's a product that comes to market and there is a potential issue with it, then all parties are brought together from the FDA to discuss how this issue may have arisen, where it is at the moment, and what to do with that from the future. And so our students enjoy seeing that perspective from all different aspects of the FDA community, and then learning how the collegial process works to best regulate the system. So there are some positive consequences of the FDA program. This has provided one of the largest draws for our Bioinnovation program. So students have applied to the program understanding that they'll have this experience. I should tell you that when they get to the FDA, they realize that it's not an academic organization, and that culture has sometimes been a little bit difficult early on, but the students embrace it and have learned quite a lot. The second note is that the device process, or the device analysis process, has helped our students to understand the regulatory process, and that has influenced how their bioinnovation products have been developed. And I think that's been one of our largest wins in this. And finally, it provides insight to careers in non-academic positions. So that was the goal of the program. The negative consequences, quite frankly, are that they take a summer away from research to do this during their first year. And so for that short period of time, their research productivity may diminish. And it's plausible that the allure of non-academic careers can cause attrition and could cause our students to leave our program prematurely. We haven't seen that as a problem with any of our students, but it's something that we're aware of. And now just to go through some of our successes in this Bioinnovation PhD program, our students are quite involved in business model competitions, taking their products out to meet with entrepreneurs and venture capitalists, and have done quite well in these events. This allows them the opportunity to articulate what they're trying to do to people from the business side, get strong feedback, and they also can get money. So this has been very helpful. I think our students have brought in over $250,000 in the last 5 years of funding to support some of their products. And then other successes are that our students have received I-Corps fellowships. So I've listed that we have 4 fellowships that have been awarded, 4 groups. I think it's now 5. These are $50,000 awards that let our students go out and really push the marketplace, push into the marketplace and find out whether or not our products will be of value. And that helps them to pivot to new ideas. We have an I-Corps site here at Tulane, and our students have been innovation fellows and such. And so that wraps up my presentation. I'd be very happy to take questions.
Okay. Thank you, Don. So again, I want to thank, Mansoor and Don for their excellent presentations of 2 different types. One focused more on undergraduate by Mansoor, and one more on the graduate side by Don. So now I'd like to take time to get to your questions, and you may actually continue to submit your questions using the online chat feature on your screen on the left side, and we'll try to get to as much as we can. So I already have a couple of questions, and I think this will be more geared toward Mansoor, I think, or even Don can chip in too, I think. What can recent graduates do to develop the entrepreneurial way of thinking outside of academic environment? And also there is follow-up questions. Are there any entrepreneurial opportunities for recent graduates?
So I think that one slide that I had, which actually had a lot of the programs available by VentureWell, and as Don mentioned also, the I-Corps. Really, there is no restriction on people going through a graduate degree to enter I-Corps. You just need to have a good idea. Usually, a lot of the universities will have a funding from NSF for an I-Corps program. And then if you take a look at programs like VentureWell, and there's Coleman Foundations, other foundations as well, they will have programs for recent graduates or people who are about to graduate that they can actually, they will take you and teach you some of these things. They are not done as a coursework, but more like focused workshops or with mentorship. So that's like I said, as I mentioned in my talk, we're trying to sort of address this particular thing, that only the people who are most interested go to these programs, but we want all the students to have that a little bit experience during their coursework. So really, I think you just need to do a search, but I would, the ones that come to my mind are programs like VentureWell, which is really focused on medical technology and medical devices. They have several competitions, design competitions. They have one in collaboration with NIH as well that they do every year. And then even BMES has a design competition. So there are resources out there that sort of help you, but you know, I think it's not as structured then in that case. So it's more based on sort of the person has to be committed to it.
I could add one other. So you mentioned BMES. BMES has a collaboration with the Coulter Foundation, and so there's a Coulter College that I believe is in August this year. So this is an opportunity for students in design teams, and it has to include the faculty member who's the head of the design program at the university, can go and they learn about
collaborator. Yep.
Yes, and they learn about the process as well. But and I'd also like to reinforce that the I-Corps is a fabulous opportunity for our students. Coulter College is August 3rd through 6th in Atlanta. But the I-Corps is only available to you if there is National Science Foundation funding. That's the key to entry. And then the students apply, but they have to bring a couple, one faculty member and somebody else from the community. And it's a very, very good process, but a bit of a boot camp for the students as well. So I'd recommend that.
Okay. Thank you. There's another question for both actually. Is there any incubator opportunity in your campus for these activities?
John, why don't you take that first, and then I'll explain a little bit afterwards.
Okay. So we do have we have a maker space that is on campus, and that's a fairly more common sort of facility at universities these days. But also we have the state-run Bioinnovation Center that is downtown, and so that provides good opportunities for our students. And our students sometimes do internships there, so that's a good opportunity for students to find out about entrepreneurship and really help with the facility. So I recommend that kind of opportunity.
I guess I'll just add that on our campus, we've recently acquired some space to have that kind of an incubator experience. But since mostly we've been focused on undergraduates, we perhaps haven't had as much of a need as maybe because traditionally it's been a lot of the graduate research and graduate projects that end up turning into ventures. But I think they've recognized that now more and more undergraduates are involved with this as well. So we are in the process, and in fact I think officially we have started an incubator space, and we're trying to attract a few local ventures, both medical and non, to come and take over the space and then allow the students to come in and interact and learn from them.
Okay, so while we wait for some questions, maybe this is one more for Don. So how do you sort of teach the students or sort of provide information about this intellectual property protection aspect, when they're
right.
dealing
So
with
that's very important for both our undergraduates as well as our graduate students. So we have a strong relationship with our group here at Tulane who does technology transfer, and so they come in and speak to our students and explain issues about what needs to be protected, processes of protection, the importance of not having public disclosure until you have protected your property, and having non-disclosure forms completed if you are going to present your information to others. I should tell you that our undergraduates and graduate students are very entrepreneurial here, and there are many cases of our students taking designs that they've started as undergraduates and moved on to create their own companies, and that's quite a change from when I was a student.
We mostly address the issue of intellectual property in our classroom by telling students about it. At our senior project level, we actually collaborate with University of Detroit Mercy here, which is local, and in some of those projects, they actually have law students who would come and work with student teams to help them understand. And really, it's the student input has to be there. The students who are interested in pursuing intellectual property, we will provide them with help and support. We have a collaboratory on campus, as well as people who are more on the end of understanding about it. A few alumni, for example, will provide a provisional patent for technology that's available and exciting, sort of at a very reduced or no cost at all to students. So there is some resources available, but in the end, I think you can only go so far, and as long as the students are on board, then you can do a lot with it.
Okay.
I'll add one more
thing. Waiting for some more questions. I have actually, sorry, go ahead, Don.
Yeah, I'll add one more thing, and that is that with our PhD students, some of them have started forming their own startup companies, and there is a conflict of interest issue that has to be addressed head on, which is that if investors come in to purchase part of their companies, the university is likely to benefit from that, and we need to make sure that our students are graduating for merit based upon their research and not because the university is likely to earn money based upon the sale of a company. So that's an appropriate conflict of interest to manage, and we haven't had any problems with it, but it's something that everybody needs to be aware of.
Okay, while you're waiting for questions,
to add that conflict usually does not exist at the case of undergraduates because they're usually paying tuition, and so one of the things that I sometimes use as a carrot to tell some of the students with projects that have potential to pursue the entrepreneurial route, or at least the intellectual property route, is to say that in the case of undergraduates, in most cases, they would be the owners of their idea because they have usually worked on it as part of their senior project. So that really gets some of them excited who want to have that sort of, this is my project and I have worked on it sort of feeling with it.
I should have a question for both. As you all know that we are still these days trying to make an ABAT criteria met for all our electives. And if you offer these sort of classes, I'm assuming this is going to go under technical electives. How do you think, all of us, the students I know in our campus, like to take some of these courses, but then, so you know what, can I get a credit for technical elective for this class? If not, because this also happens also for some, physiology class-related class in biomedical engineering. So how do you think that, and especially for undergrads, they're trying to balance between the minimum requirements for ABAT and stuff, these sort of courses are going to come into their, if you offer these classes, how they're going to fit this into their schedule?
I'll address that by saying that we have sidestepped the problem by actually introducing in actual classes. So it's not a specific course that they can take. They basically, all the students who are taking core courses will have to do a project which will have entrepreneurial mindset or thinking activities or modules built into it. So we can assess them this way too, and that way we don't have to worry about sort of assessing something that may be considered as non-technical. And I took a slide out, but I want to emphasize that if somebody is aware of the assessment processes that ABAT uses, you really should go back and take a look at it because the verbiage that they use is so broad and I think inclusive that it really actually says in other words that they want to inculcate this entrepreneurial mindset in undergraduates as well. So I think, in fact, if anybody needs extra motivation to say, well, I don't want to do this because it has no consequence for ABAT, I will take the opposite side and say that, in fact, ABAT wants you to do these, but perhaps you can do it in such a way that you're not sacrificing too much of the technical content, if that's the perception.
Yeah, I would agree with that. I don't think there's a reason why this couldn't be used for ABAT. As far as professional electives, it's not wise to use the credits for professional electives to count the number of credits for engineering, et cetera, because we really don't have control over exactly what our students will take in that. I will point out that in the design process, our students are supposed to understand about economic constraints, financial constraints, and so some of those issues are into entrepreneurs. So it comes through that way.
So we have about 1 more minute. Do you want to sort of sum up anything that we didn't sort of answer in the questions, which you sort of wanted to do, but you didn't really have in your 20 minutes? I mean, we have 1 or 2 minutes total left. So, I mean, I know that your schedule will give 20 minutes. So if you want to add anything.
I'll just say that anybody who's looking for resources, one of the primary places that you find people who are wearing this kind of hat or circles where they hang out is obviously American Society of Engineering Education, the ASEE. They actually have a division that is specifically focusing on entrepreneurship, and so that's one place where you can look at a lot of the literature and efforts that are happening all across the country, not just in biomedical but in other fields as well. So if you want to co-opt something for biomedical engineering, or if you want to look at assessment tools that are being used, it's a great resource. And otherwise, you can always contact the faculty that you see. And again, I will emphasize that a lot of the people are very much willing to help out because in the end, I think we want to provide the students with the best experience. And people who are committed for pedagogy and best teaching experience, I mean, I think they are willing to collaborate as well.
Okay. I think thank you for all the questions. This is all the time we have. So if you have any questions, the participants, didn't catch your mind right now, you can sort of pass it on, and we can get it to the speakers to follow up with on that questions. So that concludes our webinar, and thank you for joining us. Please stay online and take a few minutes to complete the brief webinar evaluation before you go. We would really appreciate your feedback on that. And we also like to remind you that the webinar is being recorded for your convenience. The slides and the archived audio recording will be available on the BMES Education e-learning page, and you'll be notified by email when the archive materials have been posted. I hope you will join us in the future events of other BMES events, especially those listed on your screen. And to learn more about these events and upcoming BMES activities and events, please visit bmes.org. And again, I want to thank you, everybody. Please stay on for the brief survey at the end of the webinar. Thank you again to everyone, the speakers, Dawn and Mansoor, and all the participants for joining us today. Thank you.
Thank you, Kunal.